Given that z is 1 plus 2i and w is 2 plus I, we need to calculate each of these. So first of all, z plus w is 1 plus 2i plus 2 plus I, and collecting the real parts we get 3, collecting the imaginary parts we get plus 3i. Z times w, that's 1 plus 2i times 2 plus I. Expanding that, 1 times 2 is 2, 1 times I is I, 2i times 2 is 4i, 2i times I is 2i squared. I squared, remember, is negative 1, so this becomes 2 take away 2, and I plus 4i, so we just get left with 5i as our answer there. Z over w is 1 plus 2i over 2 plus I. The way we simplify these into a complex number is to multiply by the complex conjugate. So we're going to multiply by 2 minus I over 2 minus I. Remember, the reason this works is we're multiplying by 1. So we're not changing the value, but we are changing the form. Expanding the top, we get 1 times 2 is 2, 1 times minus I is minus I, 2 times 2i is plus 4i, and then minus 2i squared. And on the bottom, we've got a difference of 2 squareds, so we end up with 2 squareds minus I squared. I squared is equal to negative 1, so this becomes 2 plus 2, so 4. And this becomes plus 3i. And then in the denominator, we have 4 minus minus 1, so 4 plus 1, so over 5. So 4 plus 3i all over 5, or maybe we prefer to write that as 4/5 plus 3/5 I. Z star, now remember that means the conjugate of z, so that is the conjugate of 1 plus 2i. And the conjugate just means take the imaginary part and negate it, so it is 1 minus 2i. Finally, the conjugate of z divided by the conjugate of w, so that is 1 minus 2i, which we worked out here. And the conjugate of w, 2 plus I, is going to become 2 minus I. And then we approach it in the same way as we approach part C. We're going to multiply this by the conjugate of the denominator over itself. So 1 times 2 is 2, 1 times I is I, minus 2 times 2 is minus 4i, minus 2 times that is going to be minus 2i squareds, over, again, difference of 2 squareds, 2 squared minus I squared. The I squared is negative 1, so this becomes plus 2, so it's 4 minus 3i over 2 squared minus 1 is 4 minus minus 1, 4 plus 1 over 5, or maybe 4/5 minus 3/5 of I. Now in particular, that last one is an interesting one because there is quite clearly a relationship between these two. And perhaps you could prove that that is always true, that relationship. Have a go at that and see if you can show that. In the rest of this skill, that's what we're going to do. We're going to look at some properties of conjugates. So if we take conjugates of things, can we work out what they are equal to in other forms?